I guess we're live now. So welcome everyone for our weekly live stream on Twitch today. We're glad to have Andrii Rodionov to speak about real-time stream processing, and we will have a cool demo about face recognition. Other demos also you can do with JET and stream processing. But before we start, I would just like to go through our announcement for the real-time stream processing and conference. So this will be happening next week, and essentially it will be great if you can join us. So I'm just going to share the screen now, where you can see where you can sign up. So it's hazelcast.com/unconference. So it will be a mix between in-person training if you are in London, and as well you can join the roundtable discussion anywhere from the world. We will have some expertise from in real-time stream processing, as well as community members, benchmarking, and some cool stuff. So make sure just to sign up here and get your details, and we'll send you an announcement basically when we go live as well. So with that being said, welcome Andrii. How are you today?
Hello, Fawaz. Thanks. I'm great, and I think my demo will be a cool start for those ones would like to join to the stream processing engine and understand why we need the real-time stream processing.
Okay, so you get
yeah. So we can start. My name is Andrii Rodionov, and I am a Hazelcast software engineer at core team. And today we will talk about why we need real-time streaming, and I will show you an example what you could do with real-time streaming processing. But before we start talking about stream processing, let's understand, do we really need the streaming and do we need the real-time processing? And it is absolutely okay if you don't need it. So, for example, if you have the usual, for example, newspaper app, or you have some conference app, everything you need is only what customer or your client need. When it is the request response model, and when the client needs some information, it or he or she will go initiate the request to the database and obtain the information. So, for example, we will have here the cool graphics where we can show from no real-time processing data for real-time processing data requirements, and on the x-axis there will be how often the data will appear to your application and what we could do with those data. For example, as I said before, the conference site doesn't need the real-time processing application, and the customers or users don't need the real-time response from this. So it is okay, and you can continue living with this as usual. But if you would like to have some periodical ingestion from your data and processing your data in a batch manner, you could put some scheduler. This schedule will take some portion of data from your application database and send it to some processing or analysis. And there you can build some funny dashboard, some graphics, and so on. Depending how often this batch processing will be happened, it could be from 1 day, 1 week, or maybe every 5 seconds. And if the frequency of our schedule will be increased, we will be almost jump to the real-time streaming. So, for example, for batch processing, if you would like to show for your management the sales dashboard, it will be okay to do it one per day or maybe 1 per week. In theory, you can generate it every second when new items have been bought, but it is now make sense to build the real-time streaming platform and update the dashboard to show the management, because management doesn't need to know when any items has been bought. For management, it will be more interesting the time period, for example, for 1 week or maybe for 1 month. The same could be applied for delivery tracking. For delivery tracking, it will be better to know when your item will be delivered and where it is now. But it also not need to update every movement of your delivery. For these reasons, you should track this item via some GPS and so on, and it could be important only for very, very important items. But for usual delivery tracking, you only need to know when it will be arrived and when you can pick up it from some kind of post. And for this reason, it is will be okay to have some kind of the batch processing. But there are a lot of situation when you really start needing the real-time streaming. You can implement it by using simple, for example, PubSub messaging platform, for example, RabbitMQ, Kafka, and so on. And you could, for example, connect your PubSub platform to some CDC and take or grab any changes when new item will be inserted or a new row will be inserted to your database, and then send it to some aggregation or analytic platform. And it is also cool, and it is also could be implemented with very simple messaging processing platforms. And you could do this some things like rideshare application, for example, to match the taxi driver, the Uber driver, or Lyft driver with the place where you can get and find the optimal price for your ride. And that is more important. For example, it could be the real-time stock trading. If you are, for example, implementing some trading bot, it should react as fast as possible to every incoming message and provide or implement some actions, for example, sell or buy another stocks. And to implement this, it is not will be enough simple PubSub messaging platform. For this, you should have some more complex platforms that could support a lot of scenarios. What scenarios we can consider and when we need the real-time streaming? For example, it could be, like I said before, real-time analytics for business to make the in-time decision. It could be an anomaly, fraud, or pattern detection in a real time. It could be complex event processing, and for complex event processing, you could have the additional possibility to join several streams of data, to apply some transformation of the incoming data, and in some way to process them. Also, it could be the real-time monitoring, feeding, and generating real-time dashboards. Also, it is very popular now to have for middle or large organization some installed CM applications that should in real time monitoring the security and any events that could be influenced to the security. And it is also demand the combination of events from different logs from your computer system, and make some aggregation of this log and detect some attacks patterns. And it is also very complex software. It also could be used for real-time ETL processing, and also used for event-driven architecture. And of course, for modern machine learning, if you would like to implement some incremental machine learning where new incoming data could enhance your existing model, and your model will be evaluated during the new events will become and available. And for this number of use cases, it will be not enough for you to have the simple PubSub or messaging system. You should have more complex complex system. And this complex system we will call the streaming platform. The streaming platform should be able to obtain information from different sources, from different databases, apply a lot of complex transformation, and be able to save or provide the processed data to another system, subsystem, or another databases. And for this reason, you really need some streaming platform. Let's discuss what the streaming platform should have, what characteristics it should have. First of all, there should have a number of sources where you could fetch your data. It could be some simple messaging queue processing systems, or maybe IoT devices, or maybe some file watcher or socket or database events, or in many cases, you maybe need to implement your own connector for example, for some unknown device which could provide you the real-time data. After you have the source and you have the implemented or have used the existing connector, you could pass your data to the streaming processing engine. Streaming processing engine should be able to apply a lot of complex transformation, and it should be able to combine different streams, find patterns, implement windowing, and so on, and a lot of other things. And after it processes the simple event, it should be able to sync this event to some things. So as among us things, it could be some file system or another subsystem or database or another messaging queue systems. Besides this, your platform should have ability to connect or implement a lot of clients where you could implement your application, or from which you could implement additional sources for your streaming processing engine. It should be a lot of languages. If it will be all languages that we know, it will be the best platform. And that is the basic characteristic of the systems. And if we going into detail, we should add the additional characteristic, maybe non-functional characteristic. For example, it should be the processing engine should have a rich number of different operations. For example, a lot of ability to apply a lot of transformation, different kinds of aggregation, grouping, joining, windowing, and so on. Besides this, the platform should be the fault tolerant. So if it fails about any reasons, it should be restarted and do not lose the customer data. So it should be the fault tolerance. Also, it should support the data locality principles. The data locality says that the data operation should be run on the place where the data is located. So by this, we would like to minimize the number of data movement from one node to another node, because if you are working with the big data, it is very hard to move this big data between different nodes, and if we minimize the number of this movement operation, we could increase the speed of the our processing platform. Besides this, the platform should support the scalability. For scalability, it means when you could add that you should be able to add additional processing stream processing engine, and this stream processing engine will take the part of the load from the existing one, and in such case the speed of stream processing should be increased. And also the scalability will go together with distributed capabilities, and with distributed capabilities, you could also distribute your load dynamically distribute your load depending on how many instances of the streaming processing engine you are running. And of course, and it is the obligatory function, your platform should be observable, and you should have the ability to monitor and to find the bottlenecks during the stream processing, and evaluate how your CPUs are used, how your network is used, and so on, how many instances are running, and another possibilities, for example, to pause some instances or move load from one instance to another instance. So it is the basic characteristics of the any streaming platform if you would like to choose one. To show you some example how the real streaming processing platform could be work and could be implemented, let's consider the real-time demo. This demo will be processing the video that will be taken from the webcam, that it will be sent to the Hazelcast platform, where we will apply some transformation. For example, it will be grayscaled and will be applied face recognition. And after it, the resulting image will be sent to the Hazelcast topic. The Hazelcast topic will be our sync, and to this topic could be assigned different clients. In our case, it will be the Python client, and as it is the topic, so it will be duplicate all messages to their subscribers. We will also implement the Java client. And let's start with our demo. For our demo, I will be use Java and Hazelcast Jet. And as you can see, here we manually implement the new stream source, and it is implemented by using OpenCV library. And what I'm doing, I'm taking the video from using the OpenCV library and put it into the so-called stream source. So it is the custom implementation of the stream source. After this, I start the pipeline, and for pipeline, I implement two map steps. Well, the first step will be grayscale our images taken from the webcam, and the second step will detect the face in our image. And after this, the resulting image will be sent to the reliable topic. It is the Hazelcast topic. So let's start with this. So I will start the pipeline that will produce that should grab the images from the webcam, and now I will start the Python client. And on the Python client, you could see my face, and the another client, it will be the Java client, and I will start it also. So we could see, we should see now the two clients, and you compare what implementation of the clients is better. So as you can see, you couldn't see any difference between the Python client and between the Java client. It's running on the same speed, and so it is a simple clients for Hazelcast. How we can implement these clients from the for Hazelcast in Python? You could implement it in a very simple way. So you could define the Hazelcast client and subscribe it to the topic. And after this, you will add the listener, and this listener on every event message will take from the event message a frame, and then this frame will be displayed on a screen. The same approach is implemented with the Java client. So we also we also have the Java client here and subscribe to the same topic. And here we also add the message listener, and on message listener we display it the incoming message. They'll display it on our screen. And to look how the monitoring of this work, we could launch the Hazelcast Management Center. By using the Hazelcast Management Center, you could in real time see how the jobs are running, how many jobs are running. So it hasn't been started yet. Let's wait a couple of minutes. Yeah, now it is starting, I hope. Waiting for 1 more seconds. Yeah, it is a little bit loading for my CPU, so we should wait a little bit. Yeah, now it is fully starting, and now we could see that we have the jobs that are running. So this is our job, and we could see the job graph. Here's some statistics, and for every steps of our job, we could also see how many CPUs it used. For example, it's now used 8 of my CPU cores, and how many time it used, and another different statistics, CPU size, and so on. And you could see this for every every steps, how the syncs works, and how many bytes already sent to the sync source. So we could have all the observability and could monitor our running jobs. So it was our cool demo. Let me stop it, and let me stop it. Let me stop the video capture. Here. So to continue with our presentation, let's continue our presentation. Yeah. So besides, it was a cool demo. To tell you truthfully, it could be implemented on any streaming platform. So, for example, you could find the examples how implemented with Kafka platform, and it is nothing special. But let's imagine the situation that besides the real-time processing of incoming messages, additionally, you would need to save some statistics during the messages processing, or for example, enrich your data context. For example, if we implement not the face tracking, but implement the image recognition, I would like to save in some persistent store information what was the person and when the camera captured it, and for recognized person, I would like also take some context about this person. For example, it is a name and the additional information. For this, I need to have some additional data store where I should store this information, statistics information, and I need additional data store from where I can enrich my information to provide this additional context for a recognized person. You can implement this by using the additional data store, but if you are trying to do this, you will find that we have some problem. And the problem will be that we have two kinds of data store. We have the face data real store, where our real-time data platform is working, and we have the slow data, where is where could be those databases. And if you are trying to use usual databases to enrich or store or getting data from real-time data processing platform, the speed of your real-time platform will be equal to the speed of those slow data platform, and it will be decrease the speed of your whole running stream processing engine. So it will be the problem. How we could solve it? And to solve it, we could use our Hazelcast platform. And I will show you how the Hazelcast platform could help you and what additional advantages Hazelcast can brought you. As you know, there are the number of phase data stores, for example, MongoDB, AirSpy, Cassandra. It uses the hard disk to store their information, but there are a number of in-memory stores that use the memory to store and process the data, and Hazelcast is one of them. To tell you truthfully, Hazelcast was established as the company that provides the fast caching solution, and then it will be transformed to the in-memory data grid store. But currently, it is also not only in memory store. It is also provides the capability of streaming processing engine like Kafka Stream, KSQLDB, Flink, Kinesis, or Spark Stream is doing. But in the same place, Hazelcast left in as the in-memory data store. So by combining these two characteristics, in-memory data store and real-time streaming processing platform, we could take advantages of them. For example, we could use Hazelcast in-memory data structure to store some incoming data to those distributed data grids. And also we can fetch data from this data structure. This data structure are running in memory, so there will be not speed decreasing when you are trying to save or fetch data from those data structure. And after this, the speed of your real-time processing engine will be not decreased by calling additional data structure running on the same server and running in the same memory and running in the same platform. So by combining this characteristic, your real-time speed of data processing will be not decreased by using additional Hazelcast data structure, and this could give you the additional opportunities for real-time data streaming processing. To summarize what Hazelcast platform could provide you. First of all, it provides the stream processing engine. And the second, it provides a fast data management with all data structure which you could use in your stream processing engine. And if you would like to get some data from a database, you also shouldn't go directly from your stream processing engine to the database. You could use Hazelcast data platform as some proxy, like as some caching solution, and fetch data to enrich your data stream by using this cache by data that has been cached in some Hazelcast internal data structure, and you will be running on the same speed without the decreasing speed of this. So it was some intro. If you would like to play with another different examples or implement your own example, I welcome you to visit Hazelcast Jet demos. For example, my favorite one, train tracking, and another one is train collision prevention, where you can find cool demo and the source code, how it could be implemented. So that's all for me. You are welcome for questions.
Thanks, Andrii. It's a really useful demo. So I got a question here is like, what is the difference between the Java and Python clients here in this demo?
Maybe not big difference, maybe the difference only in a syntax. But they use the same approach. Maybe for some operation, Java client may be more useful because depending from the language, they are not equal support of Hazelcast for all our clients. For the Java clients, maybe the most supported client.
Okay, and is the cluster here with only one member or two members? So one member for the Java client and one member for the Python, or just one member?
It was only one member for JET processing pipeline, and we have two different clients that run as a separate process. So it could be located on other laptop by default.
And also a question about this demo. So is it available online where people can access it and try it out? Is it through the link you mentioned?
Yes, I will provide it. I should make some updates because I only yesterday added Python client for this demo. So I will update it and provide the link.
So people can basically ask question on our community Slack. Is that correct? So if they have any question about the Jet engine stream processing, we have a dedicated channel for stream processing where they can ask question about Jet, how it works, also for other clients.
Yeah, and also you could try to use the Rodionov platform where you shouldn't install any Hazelcast or Java code, and only in the cloud could run the Jet pipeline jobs or another kind of the jobs.
Yeah, that's great. I think this would be a really interesting topic by itself to have this demo running on Viridian, see how it works. Then we can compare it as well. But Viridian definitely is like worth checking and see how it's possible to run also Jet jobs on Viridian. So that's another, I think, useful feature to have, and see if the demo also will run. So perhaps we can have you back again on Twitch to see on Viridian. So thanks so much. I assume you're going to present this talk next week. Is that correct? Yeah. So good luck for presenting this, and thanks very much for attending Twitch today. And thanks everyone for also attending, and hopefully you found this useful. I just wanted to remind you before we finish that we are having the conference next week on the 9th of March, and it will be a hybrid event. So if you are in the UK, in London, you are welcome to join us in person. Otherwise, please register. You can also join us virtually anywhere from the world. We will start by having a training workshop for real-time stream processing, followed by a roundtable discussion about real-time stream processing, industry experience, and community members as well. So make sure to just put your details here so that we can contact you next week. So with that being said, thanks very much for attending, and thanks, Andrii, for your time. Thank you.
Thank you.
Yes,
Thank
bye.
you for joining.